Assalamualaikum and hi everyone. We are now in lecture 6, Transaction Management, part 4. At the end of this lesson, you should be able to understand the view serializability schedule and recoverable schedule. View serializability offers less stringent definition of schedule equivalence than conflict serializability. Schedule is view serializable if it's view equivalent to a serial schedule. There are three rules if we want to determine whether the schedule are view serializable or not, which is initial read, write read conflict, and last write. Two schedules S1 and S2 are view equivalent if for each data item X, if Ti reads initial value of X in S1, Ti must also read initial value of X in S2. The second one, for each read on X by Ti in S1, if value read by X is written by Tj, Ti must also read value of X produced by Tj in S2. The third one, for each data item X, if last write on X performed by Ti in S1, same transaction must perform final write on X in S2. Let's take a look on the example. This is how we can determine whether the schedule is view serializable or not. If you take a look, determine whether this S1 schedule, so this is the S1, is view serializable or not with schedule S2 with order of T2, T3 and T1. Okay, so if you take a look, this is a non-serial schedule because if you take a look, T3 haven't finished, T2 can start. Okay, so the first thing that we need to do is convert the non-serial S1, convert this S1 to become a serial schedule S2 with order T2, T3 and T1. So means it has to start with T2 followed by T3 followed by T1. So what we can do is, what is the operation inside T2? Read A. After we finish with all of T2, we start with T3. T3 we have read A and write A. Then we followed by T1, we have read A and write A. Okay, so by that, this is the our S2, this is the non-serial, and this is the serial schedule. Okay, so the first thing, you must have the non-serial and the serial schedule based on what the question gave you. Okay, so if you take a look, I already have my S2 schedule as follows. So let's say we have this S2 in a proper schedule here. Okay, so the first thing, there are three rules in the view serializability. The first rule that we need to take a look is initial read. Initial read. So let's take a look on how to find the initial read for both schedule. Okay, so the first rule is initial read. Okay, then we have two different schedules here, S1 and S2. And if you take a look, how many data items do we have? We have only one data item, A. If you have A, B, and C, then of course you need to do for all A, B, and C. But now since we have only data item A, so we just do A. So initial read for data item A would be, if you take a look on S1. Okay, take a look on S1 first. Which transaction did the first read? So if you take a look here, first read on A is done by T3 and T2. So we have T3 and also T2. If we take a look at the schedule number 2, the initial read also is done by T3 and T2. Okay, so by that, both is the same. Okay, both schedule have T3 and T2. This also have T3 and T2. Okay, before any write operation on A. So that's what we call as initial read. So if we pass this initial read, then we can go to the second rule. Second rule is about the write read conflict. Okay, the second rule is about write to read conflict. What does it mean here? We need to find the complete write to read operation on A. So if you take a look here, write to read operation on A is complete from T3 to T1. Write to read. Okay, write to read from T3 to T1. This is for S1. Let's take a look on S2. Write to read operation is done also by T3 to T1. Okay, the same value T3 to T1. Okay, in S1, T3 to T1 on S2. So means we pass also the second rule. Okay, now let's take a look at the third rule. The third rule here is about last write. Last write. So if you take a look on A, so let's write it first, last write. Okay, so this is the rules, last write. So if you take a look, based on S1 here, last write is done on T1. So it means here last write done by T1. Let's take a look on S2 also. Which transaction did the last write? So if we take a look, the last write also is done by T1. Does it the same? Yes. So if it's the same, then we know that third rule also pass, because S1 and S2 has the same value for initial read, write conflict, and last write. This is for data item A. If you have data item B, you need to check for data item B one by one. Okay, need to check for each data item one by one for all of these rules. So if we take a look, we pass all the three rules. So what we can say, S1 and S2 is view serializable. Okay, S1 and S2 is view serializable. Okay, let's say after you have done the first rule, the value initial read for S1 and S2 is not the same. Then if it's not the same, then we know that first rule is not passed, so it doesn't need to test for second and third rule. Okay, so but if you pass the first one, check for second one. If you pass for second one, check for the third one. Okay, so if you stop in the middle, then we know that S1 and S2 is not view serializable. However, in this example, all of the values for initial read, write rate conflict, and last write is just the same for S1 and S2. So we can conclude S1 and S2 is view serializable.
To summarize here, every conflict serializable schedule is view serializable, although converse is not true. It can be shown that any view serializable schedule that is not conflict serializable contains one or more blind writes. In general, testing whether schedule is serializable is non-polynomial complete, which solution can be verified in polynomial time or computer time. Serializability identifies schedules that maintain database consistency, assuming no transaction fails. It could also examine recoverability of transactions within schedule. If transaction fails, atomicity requires effects of transaction to be undone. Durability states that once transaction commits, its changes cannot be undone. Recoverable schedule means a schedule where for each pair of transactions Ti and Tj, if Tj reads a data item previously written by Ti, then the commit operation of Ti precedes the commit operation of Tj. I guess that's all for now. See you again in the next part. Thank you.